Okay, this screencast is going to focus on Lab 9, the Gossip Protocols lab. I'm not going to show any code in this lab for obvious reasons, but my goal in making this is to give you a better idea of what you're going to be doing, okay? So the Gossip Protocol, essentially, it's a peer-to-peer messaging system, okay? So imagine that you've got some graph of nodes like this, okay? They're not fully connected. As you can see here, Gossip 1 is only connected to 2, who's only connected to 3 and 1, etc. But we want to pass messages essentially from 1 all the way throughout this system, okay? So if I create a new temperature sensor reading on Gossip 1, for example, I want to be able to pass that temperature reading from 1 to 2, from 2 to 3, and then at this point, because 3 has multiple connections right here, it could go either way. It could go to 4 and then 5, or it could go to 5 and then 4, or it could go to 4 and then 3 could send it to 5. It doesn't really matter, and that's kind of the really cool thing about Gossip is that there is some element of randomness to this system, but it doesn't matter how the message gets there. The only thing that really does matter is that it eventually does get there. Okay, so the first thing that we want to talk about is this little cycle we have down here. There's essentially a while loop that's going to be running in our code. The way that's done in Carol is just through scheduled events. Every X amount of seconds, we're going to run some rule or some event. Okay, and that's essentially going to just run this pseudocode right here. Okay, I'm going to talk about each of these sections in just a second. Later on, I'm going to talk about the structure of a rumor message as well as the structure of a scene message. And definitely the things I talk about in this video aren't going to replace this entire reading, so please make sure to carefully read all of this. But I hope that it'll give you a better idea of where you can get started, okay? So the first function right here, get peer, all right? So when, let's say Gossip 3, when it every 5 seconds runs its Gossip heartbeat event, it needs to essentially take a look at its current logs, all the different temperatures that it has stored, from whom, etc. And it needs to say, okay, out of all my 3 connections, 4, 5, and 2, I have 3 connections right here, which one do I want to send a message to? That's all this function is saying, get peer. Okay, given my current state, who should I send one to? Now, this actually does imply that Gossip 3 has some idea of what's stored in 4, 5, and 2. Okay, now it can't be perfect because this is a very randomly built structure, but if we can have some sort of assumptions about 4, 5, or 2, then we can make better or smarter decisions about what message we're going to send and to whom. Okay, let me give you a little example of what I'm talking about. This is just the way that I implemented it. You can implement it really however you want as long as it works. I have a little smart tracker entity variable, and if you click on that, it'll actually have a list of all of Gossip 3's peers. You'll notice that there are 3 connections. That's because each one of these connections represents each one of these picos, okay? So key to that pico is essentially a summary of that pico's temperature stores. Okay, you can see where the message originated from and the highest continuous sequence number. Okay, I'm not going to talk a whole lot about that, but that's defined right here. Okay, just to kind of give you a brief introduction to it, whenever a new temperature event comes in and a new log is generated, essentially whatever pico is sent to, like let's say I sent a new woven temperature reading to Gossip 3, it would essentially go to its own logs. It would store the temperature structure inside of its logs, and it would increment this little sequence number. So the first message is going to be 0, the second one's going to be message 1, and so on and so forth. Okay. Now, although I have 5 nodes right here, I've actually only sent new temperature readings to 3 of them. So that here's the 3, and you can see them right there. And I've only, out of those 3 messages, or 3 picos, I've only sent multiple messages to one of them. And that's why this guy right here, whoever CJTUA is, his sequence number is 1 because he has a total of 2 messages that exist in this network. Okay, so don't think too hard about that. You'll kind of see why you need that as you start programming it. But for now, just be aware that that's kind of what I'm doing to keep track of other peers' states. Okay, so after I determine, oh yes, that's what I wanted to point out. So you can use this smart tracker variable, or in other words, the summary of other people's logs, to kind of compare it with your own logs and figure out, okay, I've got all these peers, and peer 1 or peer 2 CS, whatever, he needs message 2 for me. Like, let's say I had the next sequence number right here. Let's say I had sequence number 2, but I know that this guy doesn't have it. I can use this entity variable to say, hey, whoever this is, he needs number 2. Okay, so that's what you're going to be doing in get peer. Prepare message is the next function. It's pretty straightforward as well. You essentially just, now that you know who you're sending the message to, you just do some formatting. Okay, you format it, you get all the information you need ready to send it, and then you go ahead and just send it to that peer. Okay, now there are 2 kinds of messages that you could send. If you're sending a rumor message, it's going to be exactly as I described. You're going to use your own personal logs, and you're going to use the logs of the other picos and just kind of determine what they're missing and what you can send to them. Okay. Now, prepare message, however, or excuse me, scene message is the second type of message you could send. Now, this is going to be different than a rumor message because you're not actually sending a specific rumor to them. You're not sending this data structure to them. Instead, you're going to send essentially a summary of your own logs. Okay, and this is how you keep other people's smart tracker variable up to date. So if gossip 3, you can see that whoever this is has up to sequence, or whoever this pico is has up to sequence 1, right? Let's say I'm just going to pretend that that's gossip 4. Okay, this guy has seen up to message 1. What if he receives message 2 from gossip 5 or from some other node? Okay, as far as gossip 3 is aware, that guy still doesn't have it, right? When in reality he actually does. So the scene message is going to essentially be sent from gossip 4 whenever he wakes up. He's going to send it to gossip 3, and gossip 3 can essentially update his little tracker information. Okay, and that's to keep everything in line. Additionally, one thing that you can essentially determine at this point is if gossip 4 sends his little summary of his temperature logs to gossip 3, gossip 3 could immediately take those logs, compare them with his own logs, and find out all the messages that 3 has that 4 doesn't. You can kind of think of it like the difference operator on an array, where you essentially just take a big list of items and you just say, okay, well, what is in set A that's not in set B? You know what I mean? That's an option for you in this lab that helps propagate messages a little bit faster, but we'll leave that up to you to implement and kind of decide on your own. Let's see, what else? Okay, the next function, the send function. Okay, so now that we have prepared a message, whether it's a rumor or a scene message, we're going to just go ahead and send it to whoever that peer is. Okay, and then last but not least, we'll update our state. If I knew, being Pico 3, that number 4 was missing something, and I ran my little loop and I sent it to 4, I can just go ahead and update and assume that it worked. I can just increment this little variable right here and just say, okay, I'm going to assume that whoever this Pico is, that he actually received the message I just sent to him. okay? And if for whatever reason, like network failure or something, it didn't work, uh, it'll still end up being okay, because eventually Gossip 4 will send a scene message to Gossip 3, and he'll update it and redecrement that variable so that he knows, okay, I need to resend that message. Okay, so that's just a brief overview of kind of how that's working. Let me go ahead and show you one last thing, the temperature logs, okay? So this is a log of the temperatures stored in Gossip 3. He's got essentially a big map, goes all the way down to here, and it stores sensor ID or pico ID. You'll notice that it's just the pico ID right here, right? Pico ID keyed to a bunch of messages, okay? The message ID is going to be that pico ID again. You'll notice that there's pretty often redundant data in this data structure I have going on. That doesn't really matter. That's just kind of what I found was a little bit easier. But the message ID is essentially just this who sent it, the pico ID, keyed to the sequence number. And you'll notice that whoever this guy, because he had two messages generated, he's got two objects in this map. Okay, he's got key 0 and key 1. And then, of course, it's just got their individual, the timestamps would be different, but I just kind of faked it. So you would have the timestamp here followed by the temperature, and then once again, you just have reiteration of information. So you got the sensor ID and the message ID. Okay. I want to show this working for you. Okay. I've already started on all 5 of these picos. That little cycle, that heartbeat, gossip heartbeat rule. Okay. I just have a little button that I can press over here that starts it. So I just individually went through each one and started their heartbeats. So every 5 or 8 seconds or something, they're going to run that little cycle. But let's send a new message to Pico 2, okay? So let's pull open Postman right here. I've got to simulate to number 2. Let's just send a temperature of 61, okay? Send that, navigate back over here. You'll notice that his logs have now updated, okay, it looks like that's who it is, to include 61. You can see it right here, okay? Now, let's just hope that this guy hasn't gone yet. This guy does not yet have number 61, but hopefully, if this is all working, we'll see that that message is propagating from one node to the other. Let's take a look at number 1 and see if he's got it yet. Okay, yep, this looks like it's working pretty good. He now has that number 61 temperature. Let's check out number 3, temperature logs. Oh, yep, looks like he's just got it since we last queried him. Let's check number 5. Yep, he's got it as well. Okay. Oh, and you can see Gossip 4 just got that. Okay. So that's Gossip in action. I hope this video helped you at least gain some better idea of what we're expecting. And I hope that if you have any questions, you'll feel free or feel comfortable to just kind of ask us and get started on that lab. But thanks for watching and good luck.